So now that we've talked about the structure and functionality and key methods and example application of Java ReentrantReadWriteLock, let's take a step back and talk about some of the usage considerations you have to think about when considering if you should apply this lock to your program. So the benefit of this, or the goal, is to enable higher levels of concurrent access when you have a bunch of threads that need to read data that's shared between the threads relative to other exclusive locking mechanisms like reentrant lock or Java synchronized statements and methods. Performance might improve if the data is read from much more often than written to on multi-core systems. And the emphasis here is on may. We'll see why in a second. However, there are some limitations with the ReentrantReadWriteLock, and you can take a look at the link down below to learn more about some of these limitations and ways of overcoming them. So probably the most fundamental limitation is that both read and write locks with a ReentrantReadWriteLock are pessimistic, and therefore they make the assumption that contention will always occur. Now, you might think to yourself, well, how could you not make that assumption? Well, you'll see when we talk about Java stamp lock that that's indeed what Java stamp lock does. It doesn't make that assumption, or it doesn't need to make that assumption. And so as a result, if you have certain conditions, then stamp lock, which has this so-called optimistic read mode model, will potentially perform a lot better. Again, the emphasis is on potentially. As usual, your mileage may vary, so you need to always benchmark these different mechanisms to see what actually works best in practice. Another downside with the ReentrantReadWriteLock is it will starve readers or writers depending on which is given priority. And interestingly enough, in Java 5, which is where this was originally introduced, the readers were given priority. And then in Java 6 and beyond, the writers were given priority. You might ask, why did they make those change? Well, they originally gave readers priority because at least in some sense, that means you would have more potential parallelism or more potential concurrency because multiple readers will keep going as long as there are readers to be reading. The downside, of course, is that that means that you're starving writers, and because writers probably have something important that they want to do, like update the state to be fresh and new, you are actually probably making the wrong choice by giving readers priority. So because of that, they changed the semantics in Java 6 and beyond to give the writers priority, which might not be as efficient in some sense, but it's probably a better idea because when writers got something to say, we want to make sure that we listen to what they got to say. Another issue here is that readers, writer locks, and especially ReentrantReadWrite locks can be tedious and error prone to program. And it has all the same traps and pitfalls that we've seen with the earlier variants of things like reentrant lock. So you can acquire a lock and forget to release it. You can access a resource without holding the lock at all. You can release a lock that was never acquired. You might hold the lock for a long time without needing it. So these are all the traps and pitfalls that could befall you just because of the way that locks work in Java. And that's not necessarily a fault of ReentrantReadWriteLock. It's just the locking mechanisms are fairly low level if you program with these layers of abstraction. So what should you do? Well, the most important thing you should do is you should profile your program to see whether or not it actually makes sense to use a ReentrantReadWriteLock or not. Now, just to save you some time, if you don't feel like doing this benchmarking yourself, it turns out in practice that ReentrantReadWriteLock's overhead is ironically nearly always greater than any benefits it provides. So the cons almost always outweigh the pros. And therefore, what we need to do is we need to focus on the other model of locking in Java, which is the stamp lock, which is what we're going to talk about next. So you might ask, why even bother covering ReentrantReadWriteLock at all? Well, the main reason is if you're stuck in older versions of Java before Java 8, that's really the only readers writer lock in town. And so you may have to use that. But that would really be the only circumstance in modern programs where I'd ever consider using ReentrantReadWriteLock. And even then, I would probably be very careful to use it sparingly. I guess another case you might want to use it is if you need reentrancy along with readers writer semantics, because the ReentrantReadWriteLock is reentrant, as the name implies. But other than that, I would either stick with the classic synchronizers like reentrant lock or the various synchronized methods and statements you get with built-in monitor objects, or as we'll talk about next, I would go and use stamped lock.